Hey there, School of Tomorrow students. You have stumbled across, if you're wondering, kind of a teacher to teacher channel where the teachers hang out. Think of this as a faculty lounge. And I've got this weird kind of cowboy hat, and I have a Keep Portland, no, not Portland. This one says Keep Coding Weird. Oh, I got that aimed right. Can you see my shirt? It says Keep Coding Weird, but it's written in that same font style as Portland, Oregon. And I got this at OSCON, which is a conference that comes here that deals in open source. And I deal in open source. I have this company called 4D Solutions, tagline, a pioneer in open source. And the logo comes up, and don't worry, you'll get the ads, so to speak. In other words, I'll talk about my company sometimes in glowing terms. For one thing, we sponsor Oregon Curriculum Network, which is um, an independent effort to keep alive a certain American transcendentalist poetry. And you're thinking, so you're in the poetry business? And I'm like, poetry is more than just like Emily Dickinson, but I don't mean to trivialize Emily Dickinson when I say that. I really respect Emily Dickinson, in other words. But what we're looking at is a kind of modern poetry. I'm scrolling slowly through this language called Rust. And if you've been with this channel for a while, there's already been 3 videos at least devoted to precisely this program. It's gotten a little bit more complex. And I don't want you to go running away if you don't like code. I'll give you some more big picture here about these teachers in this faculty lounge. For those, we're kind of old. Like some of us go back to like when McCain and Sarah Palin were running for office in what was then the United States, still is, I guess, for most of you, for most of us. I'm in Oregon. I'm in Oregon. Um, so what do we saw when McCain picked Sarah Palin as his running mate? It was like she could see Russia, she would say, Siberia across the Atlantic. We call it the lake sometimes, not the Atlantic. You know what I mean? The Pacific, right? Way up there, Aleutian Islands, all that. It's all one ocean, one island and one ocean. That's something we talk about. See, and I'm getting this is a perfect segue. Let's just say Dymaxion map grid. You can do this too. I'm just showing you a technique. You're a teacher, you know this, right? But I still, some people are new to, like, just go to Google Images, right? Or they're new to the map. Let's say you're new to the map. Because in Boston, it's the Peters projection, right? Or is it Phillips? Anyway, check it out. Let's check that out. I think it's Peters. Am I right? Drum roll. Dum, dum, dum. World Games. So this is another one of your well-known blogs if you're in this teacher network where we teach a different kind of geometry in the sense that it's the same geometry. It's the platonic solids, but then not really. We don't categorize it necessarily. We do categorize it. We use this database, right? Put all this stuff in a database. I'm not saying you personally have to do all that yourself. We have people. So put all that stuff in a database, you know, vectors and all that, so you could actually render them to the screen if you want. But you can also just pull out the data and play with SQL. So you can do like platonics, select for polyhedron is platonic, that kind of stuff. And kablam. So platonic is an attribute. If you're one of the top 5 there on that first thing on that first row. So as you'll see in like the last video, we chop them up and we just deal with them a little bit differently, and that we're very fascinated by the way cannonballs pack on top of each other. The closest packing of spheres is much more important to us than it was to say the Cartesians, the original Cartesians. Now, Cartesians living today, loyal to Descartes, we could say, would be deeply into this already. We can say that. We can't be contradicted, really, so it's kind of dumb to say it. Commercials, Math Adventures with Python. I'm going to just show you these 2 books, and then we're going to look at the Rust code a bit. So now that you know what this channel is about, I would watch some other ones, and then only if you think, oh, okay, I'll watch the Rust stuff, stick around. Otherwise, stick with my channel, but go feet, just jump randomly around. Watch 50 seconds of 10 different YouTubes. If you know how to get to just my stash, okay, but that's a teacher training thing. So how to get to someone's Twitter, how to, all that. So we have those workshops, and you may be wondering where these schools are, where these teachers teach. You may have heard of the Gulen schools. I'm not saying these are Gulen schools. I'm saying those were kind of Turkish immersion, right? And we have Japanese immersion here in Portland. So where is my immersion, right? So you might be asking that. And so far, I'm just doing teleteaching right now because that's the easiest thing. But as for an actual campus, stay tuned, right? More than one, right? Because we want to do horses and stuff. So adventures, math adventures with Python. I've met the author a couple times at a PyCon here in Portland. He's been in the Peace Corps. He's a really smooth, cool math teacher. And he, like me, same feeling. Why aren't we teaching coding in math class? Why? Because it's so close to math, and if you bend it a little bit, it is math. And so what's the problem? So now the other book. Now he doesn't. My friend does not. Oh, I was going to check if it's Peter's projection because this is Peter Farrell. He does not get into all this polyhedron stuff exactly the way I do. That's not what I'm. There's still plenty of adventures without doing what I'm doing exactly. So just wanted to say. And then the John Zell book. This is a classic. You probably have not heard of this title. It was big in the early days of Python. And why I recommend it especially is how much it's very straightforward, but it also focuses on programming a GUI using the built-in Tickle. The TCL is, the toolkit is written, TK is written in TCL, which is a whole different language from Python. So distributed with Python is this totally alien thing on which Python's IDE depends, not even written in Python, but something called TCL, which is cross-platform and brilliant and all this stuff. So it was very open-minded of Python to be that heterogeneous that early. And Python is still that way. It's kind of interesting. Okay, and that brings me to Rust, because we're adding to Python in Rust, right? I'm not. I'm still a newbie here, so don't expect fancy Rust. Rust is a computer language. And I've already worked on these Quadray coordinates. And let's go to my blog here after I scroll quickly through some code. I've been working on these Quadray coordinates already in Python, right? That's what we do here in the School of Tomorrow. So scroll, faculty lounge talk. You guys already know all this in a way. Like this E module really tripped me up, and the test, I wanted to transfer this test. I was doing this, and I really got it messed up. And to top it off, I had a test runner going that did not catch my mistakes because I was using a new way of testing floating point equality. Because when you're doing volumes of polyhedrons in 64-bit floating point, you're going to find yourself wanting to do tests that involve almost equal but not quite. So I'm working on this project in a way. Koski's project. He's got a lot of the Zohm hexahedra. You know Zohm tool, right? Do I have any Zohm on this table? See, that's part of the problem. I'm not a super Zohm guy. I do have Zohm around here. You know that toy, right? That's what we use in the school some. Like, school's in the planning in many cases. Until you guys have Zohm, we can't really do this. But there's also virtual Zohm. Check out VZohm by Scott Vorthman. So Peter's projection. We're back to that question. And then Russ. But so we were looking for a global grid, the voters. We were the voters who studied general systems theory back when the Bucky was doing World Game. And so there was a generation, you could say boomers and earlier even, a lot of pre-boomers actually, like Applewhite. And we were just like, okay, let's get on with like the engineering here. And so we're all into this global grid you've probably read about. It said it to be a Chinese idea these days, but in World Game it was not. We're talking a hydropower grid, or FED, however, various distribution and sinks and whatever. You know what I'm talking about. So missed opportunities is where I say, you know, we could jump to this curriculum, more of us, pretty easily. And I'm glad some of us are doing it, right? So OSCON 2019 begins. That's what I'm talking about with the shirt and Keep Portland Weird and open source and pioneer and open source. And so missed opportunities, why Peter's projection again? So this is a whole entry point where we use that map, not the Peters projection, to show the grid that Sarah Palin and John McCain never really could talk about because it's considered too, I don't know, classified. I don't know. It's not classified. It's all over the place. Go to a bookstore. Oh, there aren't any bookstores. You can't browse the way you used to, but in a bookstore you can't, but on a browser you can. I think we're going to get our heads out of our cell phones more and back to serious ergonomics where you're not bent over a tiny, tiny screen. You think that's liberation, but it isn't. You need a big screen, and how are you going to learn? You got to bootstrap. You got to have something like that already just to get into the mode of learning. So it's like first, you know, this idea that a big screen and stuff is for the entertainment that you get once you get your job, you spend your disposable income on some kind of screen, you know, I don't know. You know what I'm saying? Getting education right is difficult, isn't it? So, you guys who are learning a computer language like Rust, here's the application. I'm doing a vector math where you can add tip to tail, whatever vectors, you know this one, right? Quadrays, we've talked about that. So I've taken all these tests, or some of these tests, and I've moved them over from Python, where they've lived for some years, into what? Rust. There's the Python. So where's the Rust? There's the Rust. And I'm just going to end by talking on this a little tiny bit, and then I'm going to let you go. So the idea here, remember, this is a network of schools. We're not the Gulen schools, but we are an immersion. It's Quaker hat branded a little bit. It's not entirely owned or controlled by Quakers, I'm saying, but Quaker influence, because this is American transcendentalism, what I'm showing here. This is a side of the humanities in American literature that no doubt you have not been exposed to in school because there's kind of a boycott. There's a BDS against us, but you know, we don't care. So here we go. We've got a vector library going here with two structures, an XYZ vector and an IVM vector. And if you don't know what that is, that's where the quadray coordinates come in. Instead of using three numbers in a three tuple with negatives, in other words, negative numbers, instead, we use a coordinate system based on four, we will call them basis rays and talk about linear independence another time. We use four-dimensional, see, even that's, you can watch a whole other slideshow on why do we get to call it four-dimensional, but because it's clearly 3D, it's just solid geometry, very normal, platonic stuff. And I'm looking for my quadrays. There's the mites. Okay, where's my quadrays? It might be in a different Jupyter notebook. So we use these things called, here we go, Jupyter notebooks. And I've used these down to the middle school level at Reed College, pilot test in that case. I'm telling teachers in Portland, hey, Jupyter notebooks, this is what we need. But you can't, you know, run away from computers your whole life, right? So if you're anti using computers in a math class, I don't know, right? So I'm kind of a wave of the future in that sense. But then how do you use a computer in a math class? A lot of you already do use computers in math class. But you've never, ever, ever, ever seen this here, quadray coordinates. And you're not sure how they work. And the fact that I'm doing it in Python and Rust and that students are like running through this curriculum with those kind of skills, they don't get them overnight, right? It takes a lot of time, and I'm not the super Rust guy. I'm a prototype in that I'm showing off, you know, okay, this is the kind of thing that an open source Quaker into Bucky Fuller American Transcendentalism might be doing as part of the wider curriculum that we're learning. And so using these quadray coordinates with four coordinates, we get this data structure here where we put four floating point numbers into an IVM vector. These are the normal vectors that you might have learned about in high school already, right? X, Y, Z vectors. And then comes all this conversion from one to the other in case you want to go back and forth, which is easy enough to do. And then comes a dashboard or an interface common to both of these structures. We call it a trait. I call it the ray trait, and I implement really just your kind of Gibbsian, Gibbs Heaviside little vector math here with scalar multiplication, addition. You know, you add vectors. Teachers know that, right? If you're a math teacher especially. You may wonder why I keep acting sort of like you don't know anything, but I'm talking a lot to poets and, you know, humanities people who read a lot of more squishy stuff sometimes. But this is, you know, we have this too. We have what we call logic, whatever, kind of like Bertrand Russell had. Not that this is the same, because this is executable math. This is energy channeling, right? We're taking electrons and pushing them around at high speed this way so that we make it do a computation. We're forcing electrons to do the work. And that's kind of clever, right? Transistors behind all this. So solid state, and Rust is close to that. And solid state was the marketing term for like no tubes and stuff. And so we still have LCDs and all, but you know, we still like to have some illumination. It's not black body computing, but in any case, we're down to tetrahedron as like you can section off your library into these like namespaces. So this one's called tetrahedron. I just was scrolling through the vector there. So now I'm going to take advantage of two different ways to structure a tetrahedron. Like either way, you're going to have four vertices, right? We'll say any four vertices in space. And yet, you're going to have to choose which coordinate system. You could say, well, like polar coordinates or XYZ coordinates. And I'm saying, yeah, or we wouldn't say polar, we'd probably say spherical coordinates, right? Polar is more like two-dimensional. Anyway, I can make my tetrahedron out of four XYZ vectors. That's four vertices. They both have four vertices, right? So here I am initializing such a thing. I'm doing four rays are coming in the door. I had to be able to implement copy on the rays and vector and all this. It's not a vector. What is this? What's going on here? That's an implicit vector, right? And I'm telling it what the length is going to be. There's things I had to do here. And then I've got, I can convert that. I can convert a tetrahedron expressed as for XYZ vectors into another kind of data structure called a TIVM, a tetrahedron with the same four vertices again. But this time, each one of the four, what do you want to call them, vectors, are expressed in what? Quadray coordinates, which means 0 positive numbers in canonical form, and 4 tuples, and so forth. And the advantages of quadrays are such as we have a regime wherein only integer coordinate, all CCCP balls, I said too many C's there, all CCP balls have integer coordinates. Those are what I mean by CCP balls. Recognize those, right? Okay. So there we go, back to the TIVM and initialization of that, and they both have the same trait called volume. So then I have to implement volume for both of them, and the cool thing is I just passed the work of getting the 6 edges. We have the 4 corners. It's easy to use the distance formula in each case, quadrays or not, and send them off, send that 6 edges off to yet another data structure called tet edges. And the volume, by the time they turn into distances, we no longer care what the coordinate system was. Whether that was XYZ or quadray, we don't care. We now have 6 distances between the points. And so now let's compute the volume based on knowing those 6 edges. And so there we go. There's the Gerald de Jong volume formula, which has been I've been using that in Python already for a long time. So again, getting it moved over to Rust was not a huge deal. I mean, once I learned enough Rust. And this might be a path you want to take. start with Python because it's so um, not strict in some ways, and I don't want to give the wrong impression when I say that. It's very strict within its own rules, right? It's consistent, but it doesn't enforce the same kind of thinking on you that Rust does, because it's going to give you this whole runtime kind of cushy environment that's kind of slow but comfortable. Whereas Rust, you're getting close to the metal, and this is really a C++ kind of language, what we call a system language as opposed to an agile language. There's no like which one is better. It's like you need them both. You want these low-level fast languages like Rust here to implement on top of. You want these to be to animate from the inside, these bigger puppets, you could call them, like Python or Ruby or other languages. So you use these languages to write other languages, right? So if you're new to programming, it's not like which one is going to win. It's never been that really, but they always talk in those terms. And that goes for a lot of other games in life. The wrong question is which one is going to win, you know? It's a comic book. It's always going to have a plot, and there's always going to be like dramatic tension. So you don't want anyone to finally win at the end because you don't want the end, right? So I'm just saying, stay tuned. There'll be more. A lot of this, like I said, it kind of seems kind of jumbled, but remember that's the style I pioneer with the tensegrity approach. That it makes sense for a little while, and then I'll jump topic to something, but we kind of stay within this tensegrity. And this is by Kenneth Nelson. Those of you who don't know who Kenneth Nelson is, fantastic artist that you should study, research if you're in the art world, as many of you are. Shout out Lattice Gallery and Sculpture Conference. That was fun. All right. More sculpture, moving sculpture. I might see you at Bridges. I don't know yet. There's a lot that I'm thinking about in that score. Talk to you later.